Anyway, so what I will say is, for those who've not been following this topic very closely, whether you're overseas or here in New York City, what's prompted this rather hastily thrown together Zoom event is that the U.S. Army Corps of Engineers, which in writing for short goes by USACE, worked for many years, starting in 2015, on a massive study and then a proposed plan for resiliency, for flood protection. They had their own saga. When Trump was president, he cut the funding in 2020. That stopped it for a while. Tom Asbery, who first spoke, was the commander of the Army Corps in New York at that time. I don't know if he'll be talking about that. And then what happened was the Army Corps released their proposed plan. It was late last year, September 22 or 24, with an original deadline of something like, I think the credible date of January 6th, very loaded date in American history now. And that wasn't enough time for a lot of entities to respond. And a deadline, there was an extension to the deadline for the public comment period. And I will confess that though PortSide has been very concerned about resiliency since Hurricane Sandy, we ourselves were too busy at the end of the year to have really taken a deep dive into the plan. It's 569 pages with all the supplemental documents, it's 4,000 pages. So what we did do was we felt that we the neighborhood of Red Hook that we're in, and this end of Brooklyn, had not received a presentation from the Army Corps or any outreach, and that was possibly resulting from a transition of political redistricting, which led to our Congresswoman of longstanding, Nydia Velasquez, was redistricted out, and then with the new congressman coming in, Dan Goldman, there was no one really on top of it. So we managed to get a presentation. The two of them worked together. PortSide made some noise. Those two Congress members got the Army Corps to present. They did, and honestly, there was a lot of consternation here, as there was in other communities in New York, and it's growing, about what is a big part of the Army Corps plan is a high cement barrier wall. And so PortSide shares some concerns about that. We do not purport to be engineers or marine construction experts, so we've come up with this Zoom event to discuss possible alternatives, not endorsing or saying any one of them, but we are looking, as are many other communities and advocacy groups, for ways to create flood protection that do not look like that. So PortSide, being very focused on connecting to New Yorkers to the waterways, not the waterfront, the land edge, to maritime uses, to growing maritime uses, hard permanent walls, particularly right near the water's edge, not set back and really impede them. And specifically in our neighborhood, they could do some other things. So I'm going to do a very quick flick through some slides of Red Hook just to show here how in this particular neighborhood, we have all sorts of flooding risk, more so than some other ones, but in the city, but our story is not completely unique. So Red Hook was a Lenape territory, settled by the Dutch just seconds after Manhattan, New Amsterdam. And this map from 1767 already has a bit of Dutch influence in that running right here, the Dutch made a canal because they used waterways. And they've made some mill dams, but this shows you the amount of water within inland Red Hook. But Red Hook, the current shoreline has expanded. And so what this means is we're very low lying, but some of these mill ponds, there was fresh water as well as salt water. So it's we are at risk of seawater flooding. And then here is actually, at least I'm not sure if they're seeing mine on top. No, I don't want them to see that. I just wanted them to see the PDF, which I've lost the PDF now. I'm used to working with two large computers with two large monitors on a laptop. So this is 1874, and you can see how solid Red Hook has become, and it's filled. And so there were freshwater ponds and underground streams that are covered. And then that went faster than I wanted. So when Hurricane Sandy happens in 2012, everything that's blue on the street is what has flooded. So the only parts that did not flood in the peninsula are, this was the former Cypress Island right here. The location, a little bitty spot right here where we had our Sandy aid station, Red Hook Initiative, right over here at the edge where the highway to BQ is. Essentially, the whole peninsula flooded. Now, this here is a watershed map done by one of our advisors, Ayman Daigle. This shows all of the freshwater, or by his best estimate, freshwater streams in Red Hook. So many old timers know that, you know, Richard Street used to be a stream. Basements in Pioneer Street have flooded for a long time. Coffee Park was a pond until 1880 something. So those are freshwater issues. And then here we have the sewer shed, the blue line. So if people are not familiar with the term sewer shed, like a watershed, it represents the network of where the water, in this case, man-made pipes, the water routes are. Red Hook being at the bottom of the very high hill that characterizes Park Slope and a whole part of this Brooklyn. The sewers are designed so they collect the water up there. It comes flowing down to the Gowanus Canal, where a lot of it emerges. But when there's what they call a rain event, heavy rain, and then it comes down to Red Hook. The city had planned to have a wastewater treatment plant in Red Hook, which is why this big pipe comes down here. The community fought it, and so now the sewage is pumped up to the Brooklyn Navy Yard, up the shoreline. And what this means is that Red Hook has flooding from all different directions are at risk. So we have the seawater that come in from the sides. We have the rainwater that comes from above with climate change or heavier and heavier rains. We have groundwater that can come up from underneath. And then we have also the sewage water. And so when there are these big events, there are actually geysers of sewage that come up in some locations in Red Hook. During Sandy, the sewage burst into people's homes through the toilet. And I spoke to someone in maintenance at our public housing here in NYCHA, New York City Public Housing Authority, for those of you who are not local. And he told me that groundwater came up into the NYCHA development for 4 days after the storm. So that's some idea of our risk thing. And so now we're going to go into the presentations, and I'm so excited, so looking forward to hearing from the folks in Belgium. And actually, I realize I've been reading your company name. I'm not sure, is it pronounced Aggéres?
Aggéres, yes, it depends on the dialect and the language you speak, but Aggéres is more than adequate, yeah.
Okay. So would you like to be speaking or have your screen share now? How would you like to approach this? You have half an hour.
Well, first of all, I would like to thank you for the opportunity for us to present our company and our solutions. And I'll be presenting off, let me see, PowerPoint.
Yeah, we made you a co-host, actually. Elise did, and I forgot to thank everybody. We have a committee of, in addition to the 2 PortSide staff, 3 other committee members here, Elise and Jackie and Sarah. So please carry on. Thank you.
Okay. So we are Aggéres Flood Solutions. Our company was founded in 2010 after severe flooding in the Belgian region. At that time, we saw people wading through the water, trying to protect their houses with sandbags. And we thought to ourselves, are we really in the 21st century trying to protect our homes with medieval solutions? So we saw potential business, and we started in 2010. It's a privately held company, and we own different intellectual property for the SCFB since last year. We have an in-house flood laboratory where we can simulate floods up to 12 feet. And mainly our projects are very wide, from private property owners with manual systems up to industrial complexes and governmental projects. We specialize on 4 domains. Our main domain is mobile flood defense systems. So there where you want to have protection, but you don't really want to see them. We have different solutions. We have we design specific solutions as well. A second domain is spill barriers, mainly to keep water in industrial complexes or chemical spills into industrial complexes. A new domain is underground retention basins, where we design smart systems that collect rainwater, keep it for reuse or for infiltration purposes, because not only do we have problems with flooding in Belgium and in Europe, but the drought in summer has become a severe problem as well. So we want to reuse the rainwater. And these systems we design, they are smart, so they can act on weather predictions and can empty themselves partially or complete with a certain storm coming in, so they can take in the stormwater. And the newest domain we've been started with is water management systems, also drought and flooding related, where we see that every drop of rainwater in the past, historically, we've tried to drain the lands and tried to get every drop of rain as quick as possible towards the sea. This is a philosophy that needs to be changed, in our opinion, and we need to keep the water where it falls, try to infiltrate as much as possible, because we see the groundwater table going down quite rapidly, and trying to invent and to design new systems where we can make sure that we have a more natural flow of our water system. We work together with some of the biggest companies in our domain. We have a partnership with Aggéres de Bond, who does many of the projects together with us. So we're not a one-party solution. We depend heavily on other companies like Aggéres, like Aggéres, which we worked on several projects, and some of the other bigger companies where we are working together with. Then the product I would like to present to you is a self-closing flood barrier. It has some other names depending on how, but it has different descriptions. The first version was invented in 1998, and the new design was invented in 2008. And actually, the system has been installed more or less all over the world, from Australia to Japan. In Europe, the most of the installations are in Europe, actually in Benelux, in our area, so Belgium and Holland. But also some of the installations, not all of them by us, were done in the United States, where there is, for instance, an installation at the National Archives at Washington, D.C., which was installed by the first patent holder and has protected, to our knowledge, the National Archives at the Sandy event. Up to today, we've done up to 600, more or less. Some of the lengths are going to be metric. I'm sorry, I didn't try to put everything into yards and feet. But
it's okay, we can do that.
Okay. More or less all over the world, there is total installations are up to 600 meters in total, whereof approximately 75% was designed and constructed by us. The longest we've done up to now is the 300-meter long Spakenburg project, which was done for the Dutch Rijkswaterstaat. One of the most frequently active barriers is one is just in our neighborhood, the Q Park Antwerp project, which we've done in 2015 and activates at least 2 times a year.
The room here said wow after that.
Currently, we have under contract or under construction around 540 meters, where the biggest project we're working on today is the Royersluis in Antwerp, also our hometown, where we will design and build a 340-meter long, 2-meter high barrier. We're also working on a 100-meter, 2-meter long, 2-meter high barrier in Denmark, and then more or less we have contracts for up to 100 meters of smaller projects all around. Also currently and anxiously waiting the results, tendering on several projects, whereof 850 meters by 1.5 meters high in Antwerp, and another one which is starting to tender in Holland. So a lot is coming up in the future. This is a picture of the Q Park underground parking garage, which is a 1.25 meter high barrier, but is actually we use the water where the problem comes from. If it comes from a river, if it comes from a canal or the seaside, or if it comes from a sewage system, once the water causes a problem, the barrier will activate. I will show you in a second. This system is actually activated by raw sewage water. You don't want to go into the water but that water usually flows into the underground parking garage, making it useless at that time. So the working principle of the barrier is very simple, and the basic design, we always tend to keep it as simple as possible. It's autonomous, so it uses the force of the water, and it's always faster than the water. So it has a minimal amount of parts. We have a concrete basin that's built into the K-wall, into the ground. It can also be built partially above ground and partially into the ground, making a fixed elevation and a mobile elevation. We have the floating wall, which hangs from its lid in the basin, and a support block. This is removable. If you want to take the barrier out, you can remove this block and hoist out the barrier. At either end of the barrier, usually we connect to a fixed situation where we use guide rails. And depending on the project size, we have one or more activation pits. So once the water starts moving, as long as the tide remains between safe margins, nothing will happen. At the bottom here, there is a non-return valve, so the water cannot enter the system when it's not needed. But we designed a prescribed height at which the barrier should be activated. So once the water only exceeds by 1 centimeter or one inch, the whole system will flood from the bottom and the floating wall will rise. The mechanism of the floating wall, it's hinged at the bottom. So all the forces of the water that are exerted by the water are directly put into the foundation at the bottom. That means we can design if the barrier is 1 meter in length, or it's 100 meters, or a mile in length, it can be designed as long as you want it to be. And the best part of the system is we only have one moving part. So we get the lowest chance of failure. We don't use any electricity under normal circumstances. There is no human intervention. Nobody has to push a button. So you exclude all the parts that can lead up to failure of the system. As you saw in the diagram, once the tide recedes and we go back to a low water, the barrier itself will lower because it drains, and we'll go back to sort of a reset and be ready for a next high tide. So we have standard heights, actually up to 6.6 feet are more or less the standard heights. But we've done project calculations where we can build the barrier system easily up to 13 feet. It's a composite wall, so the floating element is in composite. It's a glass fiber foam core composite. And it's usually its location specifically designed. One of the rules, more or less, is that its depth into the ground is more or less 1.5 times its retaining height. So when you got a 1 meter high barrier, we go more or less 1.5 meters into the ground. Most of the material use is very durable, and we design the barrier for long lifespan. The costs, we get a lot of questions. What is the cost of a barrier system? But it's highly dependable on the height times the length of the barrier, and what other works will be done in the region. So even if you have a fixed concrete wall, you also need a foundation for that concrete wall. That concrete wall also will go deeply into the ground. We just changed that concrete wall for a basin system where we put the flood wall in. So it's difficult to compare to other solutions. In our current projects, we designed the system for 100-year plus design life for most of the parts. So for the basin in concrete, we take in 100-year. The floating wall is in composite because it's 99.99% of its lifetime underground with no UV light from the sun. We can guarantee a very long lifespan, and the most of the other parts are usually in stainless steel with a long lifespan. Only the rubber seals and valves, they need to be looked at and probably changed every 20 to 25 years. For future-proofing a system like this, we can design in different factors that we could imagine that from now up to 2050 we need a barrier that has a 6 feet high retaining height, but after 2050 we would have to go up to 9 feet. In that case, we can already design the concrete basin for accepting a higher wall in the future. So that in 2050, you could take out the lower wall system and put in a higher wall system without having to redo the foundations and the basins for those systems. We've been working with the product for quite some years. We have quite some experience. So we can deliver together with our partners most of the services. So we start at design and engineering part, where we do a preliminary research and cost assessment, where we can go into BIM integrations, RAMS risk assessments, composite calculations, where we could actually do most of the work to see if it's feasible to put into a certain project. From there, we can step up to do all the production works from the floating wall. Usually we do everything which is movable, we put into the ground, and concrete basins and all those things are usually done by local contractors, for which we will produce production drawings and all those things needed. Installation wise, we usually do site survey, assembly, of this floating wall and installation on site if needed. Maintenance, we use in Europe at this time, we have most of the maintenance contracts. But there we see that some of our clients, bigger clients, governmental clients, have seen that the maintenance, and that's one of the strong parts of this barrier system, is quite easy, and there is not much maintenance to do, and they take over the maintenance after a couple of times. Activation. So we designed the barrier to be activated by the floodwaters, but that's not the only way you can activate the barrier. It's actually pretty easy to just fill it with water, with any water which is at hand. So it can be easily filled by, for example, the fire department, by just pumping water from the canal or from any water body into the system, or to use city water to fill the system, or push button operation if the client would need to just push a button and have the system come up. That can also be designed, taking in always that we don't get off the path of the basic idea, where a flood will always activate the system. So we have different options of activating the barrier, but the first option, where it's activated by floodwaters, still remains its latest redundancy. In all the designs, we incorporate different redundancies, so we make sure that we have different water inlets. Those are all interconnected. So if one or two or three inlets would be blocked by debris, we just only need, for example, from 10 inlets, we only need one inlet to have the whole barrier system come up and make sure that the hinterland is protected. Basically, we design the floating wall. It's a composite wall. It's designed specifically for hydraulic conditions that appear on specific sites. So most of them are tailor-made. Our standard elements that go into underground parking garages, they are usually designed up to 2 times more or less the pressure of the static water. But for a current project we are designing, we're going up to 12 times the static water pressure, which is wave and impact pressure combined, up to 50 kilonewtons of force per meter, which is quite high. Of course, what happens when something is on top of the barrier? Actually, the barrier floats. It works like a boat. So we can design the floating part, which goes into the water. If we can expect that there will be heavier loads on top of the barrier, we can just make a bigger flotation device, so it will be picked up. Our standard barriers, they usually cope with without problems with 75 kilograms per meter. So one person per meter can easily stand on the barrier and they will just go up with the barrier. But in some cases, you would like a higher lift capability, for instance, where you could expect that there would be light vehicles or motorcycles on top of the barrier. It can easily be designed to pick up higher loads. I'm already at maintenance. So what's expected for maintenance purposes? before a storm or activation would appear. Just a quick checkup actually of the lid mostly. So the barrier under normal circumstances, it hangs from its lid, and the basin is almost airtight, sealed from the surrounding. But for instance, when there is a little bit of debris on top of the lid and the barrier comes up, and that debris actually would fall in between a crack, that could lead to a small leakage percentage. So it's best to make sure that the surroundings are cleaned. And we actually advise to do a yearly or after a flood maintenance inspection. That's usually just an inspection. And as you see, the inspection is not much more than using a pump or a water mass to fill the system. It will just make the barrier float up. You can easily inspect the seals and make it go down again. The Spakenburg project is a 300-meter long barrier, and 2 to 3 persons can easily inspect and have the maintenance done in one day. That's the reason that the local authorities have taken over the maintenance, because it's actually more a demonstration purpose than a maintenance purpose. Every 5th year, we advise to do a more thorough inspection to make sure that the seals, the wear and tear on the seals is not becoming a problem, but usually that's just a camera inspection, and to see if there is any silt or dirt gathering in the basins at the bottom. At that time, we should flush the basins. And every 25th year, it's advised to hoist out the floating walls and do a thorough checkup of the seals and probably replace them at that time. Many people, one of the mostly asked questions is, how much dirt goes into the system, and in those cases. So we've done this project. It's at a museum in Eindhoven in Holland, and actually you can see the barrier here at the bottom of this pond, and we've made it the lid of the system that watertight that hardly any water or no water goes into the system. If there would go water into the system, the barrier would come and float up every time. So only when we put in water from the bottom, the barrier will pop up, and at that time, water will flow in. This is a 34-meter long, 1-meter high barrier, which has been activated now 2 times by high water. So here at the bottom right corner, there is the river, and this is a pond, and the museum here behind is protected by this barrier. So on the right side now, the water can come up much higher than the level of the pond. And one of the projects I'm most proud of, as it was quite a challenge to make a floating barrier work underwater. I'm probably a little bit ahead of time, but this was my last slides. So we are very curious to see if we can advise or see where we can be of any assistance to Red Hook community. So I don't know if there is questions from after or we do it at the end.
No. So thank you very much. I forgot to tell everyone, I'm encouraging people to load questions or comments into the chat so we see them coming in and can kind of pace things. So our thinking was that we would take questions and comments about your project for about 10 minutes. before going on to Walter Meyer and Tom Asbery from local. And if, yeah, well, so that's what we're going to start with. I think Jackie Painter is going to be taking the questions. We saw a few in the chat, not very many. So New Yorkers are usually not so quiet, actually. So folks, questions and comments. We've got people from Belgium here up late at night to answer for us. So please speak up. So Jackie, you go.
All right, so first we're gonna go to George. Just the questions that are in the chat are George and then Daniel and then Nathan, and we just got a new question from Bruce. So George, over to you.
No, I just had a simple question, was how are these tested? You might have gone over it, I came a little bit late.
Well, actually pretty easy. We have a activation pit or a control pit, which follows the tides from the external water body, but we can close off the activation pit and just fill the system with water, or you pump it out of the canal or the river, or you put clean water into the system, and it if all the inlets are closed off, you can actually pump up the system very easily without too much effort.
Did that answer to your satisfaction, George?
Yeah, I mean, I was just curious because you have to flood it to test it.
Right, right. Okay, Jackie, you want to grab the next one? Yeah. We're going to work on my computer. Daniel?
I'm not sure you can hear me, but the question is whether this requires any supports above ground.
I didn't completely understand the question. Could you repeat it?
The floating wall, does it require any support from something else above ground to hold it from against the water?
No, actually, when it comes up, it is at the bottom. It's anchored, or it's hinged. It's anchored at the bottom. So when the floating wall is completely up, it's anchored, and it cannot be overturned by the water because all of the forces are directed into the foundations at the bottom. So it can actually, whether it's 1 meter or it's 1,000 meters, it really doesn't matter. Of course, there are some design issues with making it too long because the concrete would need to be dilated, and we would have construction issues. But of course, at either end of the barrier, it would need to seal off to a fixed wall or building or something where it would have to seal off to. Actually, the forces are not directed into those connections at either side.
And you say it could go up to 13 feet of water, it could hold back.
Yeah.
Okay.
Of course, if we have a 13 feet high barrier, we would have to go more or less something like 20 feet into the ground with the foundation and the basin. And actually, what we've noticed in some of the latest projects is because we can make the composite so strong that the composite or the floating wall is not the issue into the design limits, but actually the forces that we put into the foundation and the concrete, those forces are that big that there are special design needs at the foundation to be able to direct the forces into the foundations.
Okay.
Awesome. Thank you. And the next question, I believe, is a multi-tiered question. Nathan, do you want to unmute yourself? Oh, okay, cool. So I am just gonna, he asked, I got it. What is the cost per 100 feet per a quarter mile or whatever cost, I guess he means? And what are the solutions for waste pipe from the beginning that are not inside the wall? And then obviously to take into account that warehouses that are from 1890. And I think I'm just gonna paste what he said in the chat as well, if you can't remember what I just said. And then he also has a second part to his question, which I'm also pasting, which is what is the footprint?
Oh, as I told before, is the cost per length is very different. If you got a small opening of only 5 meters wide and 1 meter high, the cost per meter will be much more than when we have a project where we have to do 200 or 300 meters and have a sort of but well, depending on the project size, it's anywhere between 8,000 and 20,000 per meter. But it has such a wide range that it's difficult to make any price. If we have a valid project and we can calculate it, we can quite easily calculate some of the prices if we know more about a certain project. And then what is the footprint from the front facing the water to the back inside? So the foundation width, I suppose, is meant, is usually around 1 to 1.5 meters. So that would be 3 to 5 feet, something like that, with the foundations, with the concrete basin, and then the wall sitting in between.
Okay, yeah, I think that, that answered that one. Jackie, have you got another one there?
Yeah, this is Bruce's question. Bruce, you wanna yourself or do you want?
Bruce Rosen?
Yeah.
There is a question about adapting to sea level rise and higher barriers. I think I mentioned that earlier. Is if we already know that in a couple of years' time higher barriers will be needed, we can already design the basins that go into the ground are deep enough to put in higher walls in a later stage. But we have different techniques to alter the foundation and the walls, where we heighten the floor level and can put in higher walls in a later stage. So there are some adaptations possible afterwards. Wastewater, we have different barriers already activating on wastewater, on raw sewage water, which are there are pampers, there is everything floating in them, so usually no issue at all.
Okay. Fine. Okay. So actually, I have a couple of questions myself. I saw, first off, are there any property owners here on this waterfront property owners on the Zoom who would like to ask a question or make a comment right now? I'm going to give that a pause. I saw Hughes Marine was here. Do you have any questions, Hughes Marine?
Hi, not so much a question, more of a comment. Can you guys all hear me?
Yes.
Okay, first off, good evening. Thanks for having me. on setting this up. I'm here representing Hughes Brothers. We're a 6th generation barge company and vessel repair facility with a small shipyard in Erie Basin. I just wanted to talk briefly about the gates going up. There's one of these such gates going at the end of Columbia Street, which is just north of our property. We're outside of the walled-in area. So once this goes up, that'd be our only access into or out of our property. So I'm kind of interested. I love the idea of the surge barriers. We're all for that. For something that gives us the most up-to-date access to our property that we can get in close as possible to the storm to make sure we're securing all of our vessels. Any of those vessels, obviously, if something was left unsecured and we were unable to access it, that could turn into a battering ram in a storm and slam into this wall and completely undo any good that it would be doing. That being said, if any of the storm barriers or vessel or storm barriers that you guys secured, if any of those had issues where they've had a vessel strike, and how did they react to that?
Up to now, we didn't have any barriers with vessel strikes, or we have one installation which was battered heavily by a fast-flowing river and that had big boulders and stones in it, which didn't really impact it because it's more or less a parallel parallel force which is exerted on the wall. But as if we design the barrier for specific hydraulic loads and specific needs, and we have to take in account that if there is a possibility of ships ramming the barrier, that we or take out the risk of it happening, or make sure that the composite is sufficiently strong. But there we would need to see that what kind of ships are expected. There is a possibility where you would have the floating wall where it comes up, and just before the floating wall we would have steel piles with just the same system that come up to protect the wall from very heavy loads. And the steel piles, they would float up in just the same way as the wall system. So it's like it would take on the force of the ships and not make sure that the ships cannot get up to the point of the barrier system.
Sure. And I just want to stress, I don't think there's any reason to believe any of our vessels or any vessel would be an issue with this. I was just more curious once that came up, how that would be handled. But during Sandy, we had all of our vessels there. All of our vessels were properly secured because we had access to the property. So that's just very important that we make sure we maintain access up to close as possible time of the storm, so we can know our own vessels as well as other vessels in the area and help people get their stuff secured if they're unable to get back to the area. So
that's also something which is possible, that we can the inlet pipes, we can have them at different heights, so that, for instance, the big wall system and those systems where there is no evacuation routing happening, that they already close at a lower tide level, but that where you would have evacuation or service roads, that they really come up just already when the quays are starting to flood, and that everybody really needs to get out of the region, and they really pop up at just.
Oliver, je geluid staat uit. So Oliver, in
Hey,
Dutch.
sorry, Oliver, you were muted somehow. Can you repeat what you said?
So you did you hear about the?
It was just the last, not quite minute.
Okay.
What
So
I'd
we.
like to know, because we've actually run over the Q&A time with this now.
Okay.
What I'd like to know is, there's some questions posted in the chat, but I want to ask another one. Oliver and Anthony, are you willing to address the questions in the chat later? Are you leaving? Are you at this hour? Are you able to stay a little bit longer?
I'm able to stay a little bit longer. I got another colleague here who could probably help us out with trying to answer some of the questions. But we'll hang around and listen to the rest and try to answer as many of the questions. I don't know if there would be a printout later that we can.
Yes, we
view.
will be sharing the recording in the chat. Here's what,
Okay.
maybe we won't have any need for this, but my understanding is I saw a staff member, Dan Wiley of Congresswoman Nydia Velasquez, and that Kristen Rouse of Congressman Dan Goldman were going to be here. And because those two have some leverage with the Army Corps, I wanted to see if either or both of them had any question or comment before we move on to Walter Meyer's team presentation. Dan Wiley or Kristen Rouse, do you have anything that you want to say or ask? Nope. All right. Well, then there we go.
Kristen Rouse, since it's in her district right now. Kristen, if not, I did put in the chat a question about the Civil War era Beard Street piers, which, you know, go back to the 1860s or something like that. So when you have to rebuild the entire pier bulkhead, you know, and also, or where would you align the barriers in relationship to very old piers? Of course, you come from a country that has old piers.
Well, actually, I wondered that one because they're probably not likely familiar with it. I think, Dan, that those are actually wharves. They're on large stone boulders. So I would have presumed that the wall would have been, their wall would have gone out into the water, because you would probably damage the buildings. Jackhammering through boulders would be crazy land. I mean, that would be my supposition.
Right. And just as context, I think there's a combination of different things. And I know that what used to be timber crib was probably pulled back. So you have riprap and all kinds of different things to keep the piers going. We've lost pier space, like where David Sharps's barge is, you know, where it's more riprap edge instead of a bulkhead edge.
Right. Actually, you're right. There was what you call timber crib. They called it relieving platform. I don't know earlier what that was. It was very Victorian technique. They were like basically tree trunks laid this way with wood at this end, and they filled in a mixture of gravel, rubble, sand. Some cases they're boulders. My guess is digging into that dam would probably damage all of it. It would be more of a mess. You'd probably want to go offshore from that. But I don't know, are any of the O'Connell property owners here on this call to answer how their wharves are actually built? Calling once, calling twice. Nope, they're out. So, yeah, that's a good question, Dan. Is anyone from Dan Goldman's staff on right now? Okay, if not, we're running a little late to get over to the presentation by local. So Oliver, there's a couple questions in the chat. Yes, we will be sharing the chat, and if you're really willing to answer that after this, that's extraordinary. We will be posting all of this on the blog that we sent you earlier relating to the Army Corps, and then posting that like mad on social media. A lot of people I know, there are people who could not make tonight. Normally there aren't Zooms on Monday night, but there were a few, including a big one on the mayor's new plan for the city of Yes by the Department of City Planning. But we heard from people who wanted to get the links afterwards. So I thank you again profusely. So now we're going to segue over to local, having Walter Meyer kick it off. We met Walter when PortSide and he and his firm, we both got awards from the Obama White House for our Hurricane Sandy response work. And so he's developed quite a resiliency practice, and I'm very excited to get caught up with this because we actually haven't been in touch the last several years. So take it away, and I guess we have to share the screen here for you. Here comes Elise. Wonderkind. All right. Is that right now? Yeah, he should be good to go. He should be good to go, Walter, we think. Share the screen. I can't hear you. Are you muted?
How's my audio?
Now I can hear you. You seemed to be speaking before, but I wasn't hearing you.
Okay, I'm gonna stay close to the screen so you can pick me up. All right, so.
It's not terribly loud. I don't know why.
Okay, good to know. All right, let's see here. I want to add, it's great to see the team at Aggéres present, self-deployed barriers. I first saw their technology over a decade ago in New York City, and still dumbfounded that it hasn't been built in any city in the United States yet. We need that technology. I know maintenance is always a struggle in the United States, long-term maintenance, but we can overcome that. In fact, I've always introduced the idea of surge-powered barriers in the 3 coasts that our firm has worked at, and people get excited, but I think it's time to get some pilots going. So hopefully New York City is the place for that, especially in the Dutch history of Red Hook. So I'm Walter Rodriguez Meyer, landscape architect and urban designer, owner of a minority-owned business, local office, landscape and urban design. And before meeting Catalina, what really got us in position to support Hurricane Sandy after New York City is Dan Wiley, who's on the call, who represents Nydia Velasquez's office. Back in 2007 or 8 or so, Dan and Nydia brought some of the work I'm about to show you to the Congressional Hispanic Caucus, and our firm was awarded Innovators in the Green Economy, and that from that time on, it really helped our firm grow in Nydia's district and put us on the radar for the Obama administration once they got going. So I just have to say, I'm always grateful for what Nydia has done for our firm and for minority-owned firms in New York City. I'm also joined by Commander of Army Corps New York District and former Commander of Honolulu District, Tom Asbery. Tom is educated as a landscape architect and one of the only that I know of national leaders of Army Corps who's educated as a landscape architect. He's educated as well as an architect, but first and foremost, his work during leadership at Army Corps was when these HATS study was being developed, and most importantly, the New York district leads other districts nationwide for the amount of nature-based features and natural infrastructure as a priority over the hard gray infrastructure systems. So as in supporting Army Corps of New York through the years, Tom and I were interacted, and now that he's into retirement from the federal government, he's joined a local office as our federal works director. He's DC based and able to influence policy from DC. And he's joined by in addition at our DC office is Scott Davis, who is a FEMA and HUD former executive who's now in practice. And so all of us are putting our heads together on how the federal government can align with city and state entities to push these resiliency projects, natural infrastructure to complement the conventional hard infrastructure systems that typically get built. Tom, if you can take it away for a second and talk about a little bit about your background and your time in New York District.
Yeah, hey, thank you, Walter, for that introduction, as well as Carolina, this opportunity to speak tonight to this group. It was an honor to serve in New York for the 3 years that I did from 2017 to 2020. And as Walter mentioned, we were leading the way with this implementation of natural and nature-based features. A lot of that work was done through the ecosystem restoration in and around Jamaica Bay. And we're always looking at opportunities, how you can incorporate those natural features, but provide the same risk reduction measures as you would from, a structural solution such as a flood wall. So it's always a pleasure to serve New York and all the different stakeholders.
Thanks for your time, Tom. And I'm also joined by Jenny Eugenia Papistoff. She's one of our environmental scientists at local office, and she'll be managing the chat as questions come up. And she's gonna be dropping links into some of the New York Times articles about our projects as I present them. as well as New Yorker and Fast Company and a few other journals written. I'm going to show you some of the newest projects first, and then if we have time, we'll get into the older projects that have been tested by extreme flood and wind events. So the bulk of the work I'm going to show you, for those who don't know the coastal zone of Rockaway, we're working mostly in the urban coastal islands of New York State. So that's Coney Island, Rockaways, and Long Beach. Long Beach is just outside of the city. It's part of Nassau County, but we treat these 3 urban islands as one cohesive system that protects the bays behind them and the property behind that. In working in coastal zones, whether it's Red Hook or in the Rockaways, it's always a challenge to deal with the confluence of what happens when it rains and you have storm inundation. And that's water from the sky and water, fresh water and salt water coming together at the same time, which happens during some events such as hurricanes and storm surges. And so one of the challenges is really groundwater management, because what happens is the groundwater will rise up because it's fresh water. It'll rise up more rapid than the salt water because it's buoyant and floats on top of it, especially in the subsurface. And a lot of our coastal zones are very porous. We have very porous geologies in Rockaway with sand, and coastal zones of Red Hook. And so how can that groundwater be managed in a way that is consistent? The great thing is, 1,000 years ago, there was a coastal forest in New York that would lower the groundwater in the first few feet of the groundwater zone. So there was a check and balance system 1,000 years ago. And so the challenge is, how do we take the way we plant trees today and bring back that check and balance between groundwater and trees? How was groundwater lowered? It was through evapotranspiration. And so evapotranspiration is when the hotter it gets, the more the trees pump water from the ground and help cool the urban heat island effect above. And so, knowing this knowledge, there are ways to design our soils so that we can supercharge that relationship from 1,000 years ago and actually have our urban forests be supercharged in a way that can handle stormwater, groundwater, and create roughness and surge in ways that is even more improved in performance than that forest from 1,000 years ago. And this data is based on a few reference points. The USGS has noted that a mature tree can put 100 gallons per day from the groundwater into the air, but that's mostly temperate trees. Now, we've learned in the tropical environments, with groundwater sensors placed in the tree islands of the Everglades by Florida International University, the groundwater is lowered by 1/4 inch to 1/8 inch per day, which doesn't sound like much, but when you add this up, it starts to add up to millions of gallons per day when you have a forest that works in this way. And so our challenge is to learn from that regenerative system and restore it into today's city with all of today's city's cultural requirements. 1 second, my slides are stuck, so let me try to recover it. 1 second. Okay, there we go. And so the way we plant trees today, kind of on the left, it creates some hazards in the urban environment. When trees knock down in storms, they lift up sidewalks, they create disaster recovery budgets that get blown. And most importantly, the trees are not connected to each other and they're not connected to the groundwater. Whereas on the right side, if we design our structural soils in a way that are hydrologically connected and networked to each other, trees can hold each other up by connecting to each other in winds. They can share nutrients and they can lower groundwater as well as cool the urban heat island effect at scale. And so the good thing is these cloudburst strategies are being built by the city in the future, and it's happening in higher elevations in New York City. So the DDC and NYCHA are starting to deploy cloudburst contracts where they're managing extreme rains. But the challenge is most of the green infrastructure guidelines for New York City require 3 feet of freeboard from the bottom of the green infrastructure to the top of the groundwater elevation. That means that you need a 5 to 6 foot freeboard between the street level and the groundwater, which basically eliminates most of Zone 1 of New York. But my colleague from DEP, who works on these guidelines, John McLaughlin has told me those are just guidelines. They're not regulatory. And yes, the city is working uphill with its pilots, but it'll start moving its way downhill. And so some of the projects I'm going to show you now are pilots that have been built in New York that have been tested by extreme events of groundwater flooding and nuisance flooding, as well as extreme rain events like Hurricane Henry and Hurricane Ida that came through a couple summers ago. This first project is on the coast. It featured a new urban dune forest built behind the boardwalk in Rockaway to create roughness and friction so that if the seawall and the boardwalk, which are designed for a 100-year surge event, if they're ever compensated and had to be, if there's a surge that came over the boardwalk, the forest creates another layer of protection and friction, as well as the topography. So this is an affordable housing complex. This is much like the NYCHA Red Hook houses, but this is HDC and is a former state affordable housing complex that was called Mitchell-Lama. But on these microsites, working at the multiple block scale, we run these heavy rain events and mapping where water goes and where it collects. And this tells us where the strategies for intervening. Also mapping how we look at extreme winds from the summer versus the winter, and how that affects the existing landscape. Now, what we found on this project is the existing landscape was getting impacted by salt summer breeze that was coming in from the ocean. And if without a healthy forest, you can't get these protection systems. What we learned is that salt was going much deeper into the blocks than expected. Also, the harsh northwest winter winds in the winter made it hard for senior citizens in these affordable housing complexes to get around in the winter. And we had a lot of flooding and ponding that would harden up into ice. They had a double whammy here of wind and water. And this project was funded by HUD, federally funded. And this was a $4 million resiliency project. And this diagram you see here took all the vulnerabilities of the site. 4 million wasn't enough to solve all the resiliency aspects, but this prioritized. This showed the intersectional vulnerabilities of high winds and ponding and ice, and said in these darkest zones is where we should be focusing these sutures, if you will. And here's what those landscape sutures look like. Instead of landscapes that were high and paving that was low, we inverted that relationship. So landscape became your flood management zone. And instead of landscape that frame views, we started to create a landscape that moved the wind area up so that that Venturi effect of high winds would get above the canopy and create dense plantings that also were coordinated with the security camera zones that are required for affordable housing projects. And then lastly, a new dune forest between the private property and the public investment from FEMA that was backstopped by the growing field that Army Corps is now finishing construction, but that was under the leadership of Tom Asbery. And this is what that looks like. The flood management landscape is habitat driven, but it's 50% edible. Thankfully, a lot of the native dune species in New York City are edible species. And this is that dune forest. We work with the U.S. Forest Service to identify species that were native to the U.S. but may not have been planted in this region, to introduce them and document them. So each of these are mapped with GPS points and monitored over time to see how they perform long term, because some species perform better than others in the face of climate change. There are new pests, there are extreme heat. So some of these species do well in the cold, but not so much in the heat. And so this variability is critical to see, but also not abandon native species and go with the simple invasives that work well, but create other problems. So it's really giving native species a chance and creating diversity as well. This next project you can read about in Fast Company. And so there's a Fast Company article about beach green. Beach Green has become a model for New York City in two ways. You'll find it in the city planning waterfront comprehensive plan that was published last year. But it also was a model for New York City's Green New Deal. It's a built model for the local law 97, which is Green New Deal. And this is steps towards net zero. So this is 8 stories of affordable housing with mixed use ground floor. It's 100% affordable, working with HPD as the partner. And in this case, not only was it energy resilient with solar and geothermal and future battery system, but it also had a groundwater management landscape for the first time in Miami as a pilot. First time in New York as a pilot, and surface water management. So this uses the living street approach of porous paving plus tree roots that grow under the paving, and then bioswales to manage surface water and groundwater lowering system. So when there's walls to be built, you want to reduce wall linear footage and with more natural infrastructure. And this is one of the approaches, is to lower the groundwater over time by not fully requiring pumps. And if there were future flood pumps, which is the case with the Rockaways, the Army Corps plan for the Back Bay includes pump stations as well as levees and walls. How do you take the load off of those pumps? By having the ecosystem take down the first few feet of groundwater during the growing season. Also, playgrounds can be porous. Every surface can be porous. And there's a lot of ways to execute it aesthetically. So Beach Green, I give tours of this project to several commissioners over time from New York City when the spring comes around. So if you follow our firm on Facebook or Instagram or LinkedIn, you'll see announcements about those tours, and we'll be giving them probably the first one in April or May. The other issue is groundwater flooding when it's elevated during the king tides, right? And so the thing about the Rockaways is the ocean is your highest ground. It's a high dune, and the center of the peninsula is a low bowl, and then the bay side of it is also a medium height. So that beach bay bowl archetype is important for managing water, because what you see in the white thin outline is the extents of that bubble of water. And if you want to learn more about it, it's called the Guyben-Herzberg phenomenon, G-H-Y-B-E-N, and Herzberg, H-E-R-Z-B-E-R-G-E-R. Our strategy was to leverage that asset and use the interdunal swales that would be constructed for this project. This is a whole neighborhood in New York City that use a preserve to become a sponge in a way for the whole neighborhood that exists, as well as a future neighborhood that's being built for the project. This is really important detail, because if you look at this on the bottom, you see Army Corps, you see Department of Parks and Recreation, and you see HPD and future grants. This is our big takeaway that we're leaving for the team here, for electeds, for Dan's office. I know Dan is not your district anymore with Nydia, but for Dan Goldman, when he activates with his interface, and all the other electeds, this Army Corps piece that's being funded is one little piece of many other federal investments going on that are interagency in Red Hook. And to integrate the investments is critical, because then you start to phase them. So this drawing starts to look at that. Army Corps' investment on the beach that brought us the groins on the beach, and the Department of Public Works in the middle with the boardwalk that was funded by FEMA, and then future upland strategies that deal with rain. All this needs to be looked at in an integrated fashion that also takes into consideration the election cycles as well as the procurement cycles for the different federal agencies. So this project is called Arvernese. So it's 90 acres of New York City land that used to be bungalows that were raised by Robert Moses, the city planner. And so a lot of this was rehabbing old infrastructure or demoing it and building a new city. This is a net zero neighborhood, which means all of its energy comes from the site through solar and battery and geothermal district. We've been working with NYSERDA on the very first geothermal district at scale. And this is going to have a mix of affordable housing and home ownership, both rental and home ownership units, which is very exciting. And shovels are in the ground. It's now being constructed. And we have groundwater being managed at scale, at a whole neighborhood scale, all the energy from each site. So this is decentralization of groundwater infrastructure, decentralization of energy infrastructure. And you can read about this project in Bloomberg. Bloomberg wrote about Arvernice, and there'll be a link dropped in as well about the energy resiliency aspects as well as the flood resiliency aspects. This is a multi-billion-dollar real estate project, 90 acres of land. It's the biggest thing since the West Side Yards. But most importantly, it leverages things that already exist incrementally in Rockaways, including a circular economy of farms. This is a farm owned by a Red Hook resident, David Selig, and this is Edgemere Farm. And what's beautiful about this farm is that out in the Rockaways, where he's been doing a lot of work, is food is grown here, and then it's a lot of the restaurants, that some of which are Michelin listed, and they're known in Rockaway, are buying the vegetables, and then the waste is coming back to the site by bicycle. Because there's a bike highway between all these neighborhoods, and that is the boardwalk, right? That boardwalk is a bike highway. So it's a beautiful place in America with a bike highway, with amazing clean air on the coast. And yes, there's a bohemian culture of circularity and waste reuse. And we plan to formalize that with new technologies. So this is using anaerobic digesters to not only compost that waste, but also extract methane from it and generate power to support the net zero neighborhood. The first phases of this project are now starting to be built. And so New York City's future is cloud-burst infrastructure. And this is New York City's largest cloud-burst street. What it is that green line is over a mile of contiguous natural infrastructure that can handle 1 million gallons of rain every time there's a rain event, small or large. Normally, that rain would have ended up in Jamaica Bay, which is completely legal, but we went beyond the standard of a 5 or 10-year rain event. We designed for a 100-year rain event greater than 100, and that's how it looks networked and is contiguous, and it's now under construction. And so I have some update images of some of the specifications for that, some of the details. One of the big takeaways was the interagency coordination required to pull together so many jurisdictions, right? In this case, this grate that I'm touching looks very simple, right? It's a cantilever grate over sidewalk. But on one side is DOT property, and on the other side is Parks property. And this is being constructed by the development team who's in a public-private partnership with HPD. It's under construction, so don't mind the mess, but these are just from a couple weeks ago during site visits. And I roughly sketched out all the jurisdictions that needed to come together here, but to the left, we have Department of Environmental Conservation from the state, we have Army Corps, HPD, you name it. As you go to the right, more of the city agencies, but all these had to be coordinated to manage water in an integrated way. So I'm grateful for the team that pulled this together. It's both city agencies as well as consultants who are my peers and my heroes, including Star Whitehouse, Laura Starr, who worked on the preserve. But this is a really amazing project. It seems simple, just take the surface water and don't put it in the bay, don't put it in the pipe, send it into future constructed wetlands. And that building on the left was designed by my hero, Claire Weiss from WXY. Beautiful wood building, all solar, geothermal, and it's a community center that's out on that preserve. The project will feature a lot of the greatest hits of Rockaway. The restaurant row that is in the center will take you from A train. So you'll go on the A train from Times Square, door closes, it opens in Rockaway, and you see the beach, that fresh air, the salt, and there's this main street of restaurant row that takes you to the beach plaza and the boardwalk. So I'll leave it there. That's our New York stuff. If we have time, I can show you some of the tested and true the projects from the tropics that have even more extreme rain and extreme wind than New York City. New York City, a heavy rain event might be 2 inches per hour that would shut down, the subway, such as Hurricane Ida and Henry, and cause billions of dollars in damage. But in places like the Caribbean, a 2-inch rain event happens every summer in Puerto Rico, as well as in Miami. But I'll leave it there. We've also had, in addition to working with local teams in New York, we have a great local team that we've been working with in Miami, Curtis and Rogers. Check them out. Big, Aida Curtis and Jenny Rogers also been a mentor of mine and fellow minority owned practice. So our small shops are not just checking the box in equity. We're coming from places with extreme winds and rains and have something to offer beyond equity. And it's some knowledge around extreme events. So I'll leave it there, and then we'll jump to Q&A. If there's questions about some of the tropical projects, we can show them. But for the sake of time, we're going to finish it up here. Thank you.
Walter, thank you. Thank you very much for that. That was very exciting. I want to find out more about the sure, the last one. I want to ask you specifically, I'm encouraging anyone here to get some questions and comments in the chat pertaining to that presentation. I think there's some left from the prior one. But I want to ask you, is there anything that you want to propose as being applicable to Red Hook? Walter, you've gone, your video's gone, and it looks like you're muted. Ask you, there you are again. Hi, Walter.
Yeah, I'm back on. I had to mute. There's gonna be some background noise.
Okay, got it. So, apart from ripping up all of our streets and laying that down, and by the way, when I saw that, one of those last slides with all of the acronyms for the agencies, I feel for you. I'm impressed to get everything done with that number of acronyms, agencies involved. But for Red Hook, is there anything in your practice that you would propose for firstly protecting seawater surge and not the rain or groundwater things first? Do you have any suggestions for Red Hook?
The signal broke up a little. I apologize. I'm actually in the field in the Caribbean today, so the signal's a little weak. One more time with the question.
Oh, you just really had to develop that envy. Do you have any suggestions for Red Hook addressing first surge ocean flooding?
Surge plus.
Do you have any ideas for Red Hook?
Yeah, so we're short on time, but it's a project that you can read about in Architectural Record, and Jenny can drop that link for further. But in Puerto Rico, we designed wetlands that can handle upland flooding as well as surge. And this project, I wish it had some of the dynamic walls that were shown here, because it would have lowered or reduced or even eliminated the static walls that we had, and would have just had dunes and wetlands. The challenge with dunes and wetlands and a coastal forest as a nature-based system is you have to make space for it in urban environments. So that means either pushing into the water or pushing upland into publicly owned property, as well as thinking about parcel acquisition. And part of our challenge in New York City, and this is a big deal because New Jersey excels over New York than this, which is, I'm embarrassed to say as a New Yorker that New Jersey is better at buying land than New York that has been flooded. And so they have their Blue Acres program. And I can't wait for New York City to have a Blue Acres program to go buy some of these parcels and start to create public domains that can protect the city without having to always push out, into the water. But that Parque Litoral, with a little more time, we can show that, but I don't want to eat up too much bandwidth today. But Architectural Record, look at Aggéres, the western city of Puerto Rico, and Parque Litoral, and you can read about how it both had a simultaneous heaviest rain ever measured in modern history and largest surge from Hurricane Maria. And this project allowed businesses to open the next business day and were not impacted by that event.
Thank you. I was just handed a note actually by Peter here, who was on the Zoom meeting that we had with you. Could you speak a bit about cobblestone streets and other state for people listening here? There has been a discussion in the resiliency planning circles of Red Hook about aren't our cobblestone streets and resiliency asset as they allow they're more permeable And also many people really appreciate them. They're part of the historic character of the neighborhood. I would like to see them protected. And you had a very interesting answer for me and Peter on the subject of cobblestones. I'd like you to
Yeah,
share.
I can dive into that. That's a Red Hook thing specifically, and I'll pull up this project quickly in Miami.
Thank you.
So this is called the Miracle Mile in Coral Gables district of Miami. And so
You
this
still
is
have some time on the clock, Walter, so don't feel
good
so
to know,
rushed.
good to know. Okay, okay. So this project, and I will show the Puerto Rico project really briefly so you have some visuals. I won't go too deep into it, but because you can read about it in the article on Architectural Record Journal. But Miracle Mile was covered by New York Times, as well as New Yorker magazine did a video interview. So there'll be some links dropping in for that. But you know, Miracle Mile use not cobblestone, granite cobblestone, but use quartz, which is an incredible stone. It's polished so that the idea was that resiliency would be, you know, the hard infrastructure of gray pipes. There wasn't a budget to get the resiliency metrics that we needed. So yet there wasn't that was $27 million for the Miracle Mile. We needed double that to deal with the stormwater infrastructure. So by designing natural infrastructure using, you know, these living systems, both porous paving and living street strategies, it allows us to hydrologically connect the trees to get several inches of rain being managed before it discharges into pipe. And how do we do that? We excavate down the native soil and put in structural soil, which allows tree roots to reconnect to each other and to connect to the groundwater. And this is during construction of that. And you see that in the foreground, the structural soil, in the background, the excavation required to have connectivity. This is that quartz. This is like our Miami version of the Red Hook granite cobblestone pavers. And so notice that the joints, of course, the stone is not porous, right? But the joints are, right? And this ends up being about 10% porous, but the joints are where the opportunity is. Yes, the simple answer is granite cobblestone pavers have more stormwater management at the surface than an asphalt road, a conventional asphalt road. And it's mostly about the joints. If you look at this detail on these joints, there's a couple of systems that are used, but they essentially bind the pavers and allow porosity. In this case, there's Super Sand. There's another product that's a resin bond, a porous resin bond joint. And you can see what these projects look like over time.
Walter, one thing is I'm not seeing the visuals change. It sounded like you were referring to specific images.
Oh yeah, are you seeing images? I might have.
No.
Let me
I'm seeing a
stop
static
there.
screen with your company's
Oh, I
logo.
was showing images. Yeah, thank you for stopping me, Carol. Let me try resharing. I think
Let me make sure I've got this right for you. Do I have share a screen for him, folks?
there we go. Yeah, we're good. All right. There we go. All right. Thanks for stopping me. Yeah, this is Miracle Mile, right? This is the overall district. This is the cutaway of the hard infrastructure pipes underneath, and then the new living infrastructure above, showing that you don't have to spend money underground on pipes. You can spend it on beautiful systems above ground and get better performance than those pipes. This is showing the excavation to have continuous root zone using structural soils that supercharges the capacity of these trees to absorb stormwater. And these tree roots can connect underground of existing, of proposed paving. In this case, we talked about Red Hook granite. This is the quartz. And notice the joints, right? The joints are porous. So the rock itself, the stone, not porous, but the joints are. And this is a granite detail here. So before this was quartz and this is granite. And in this section, you'll see Super Sand product, as well as there's another product that's porous resin bond. The goal is to get as much of those joints as possible. You end up with a high percentage of stormwater management, even though it's not completely porous. And in the end, this might be 15% porous. But also aesthetically, you want to have the patterns communicate the resilience, right? So the other piece was I talked about Puerto Rico. So the Architectural Record article covers that. The city of Aggéres had stormwater pipes leaching into the bay, and this is an opportunity to convert these into wetlands that can handle that runoff. And so we constructed new wetlands, dunes, and a coastal forest planted out. 2 kilometers of coastline, working closely with the regional DEC in New York State. For Puerto Rico is the DRNA, Departamento de Recursos Naturales, to transfer federal guidelines around phytoremediation, or the ability of plants to remediate soil, to Puerto Rico. And this was working with the governor of Puerto Rico at the time. But the question is, can we do this in Red Hook? The answer is yes. When you look at the Army Corps studies for HATS and the walls, it's really about minimizing linear feet of wall because they're expensive. In this case, we integrated walls where as a spine of the project, but you know, the wall is designed to be buried as much as possible and never have to do its job. It's the natural infrastructure in front of it of wetlands and dunes that can absorb that runoff from rains as well as the surge. So it's a multi-layered event, and it was tested by Hurricane Maria, and architectural record documents some of the benefits from Parque Litoral. Now this sheet pile seawall you see in the background, in a perfect world, that would have been a deployable seawall, and would have, you know, had lower elevation visually and been a little more discreet and hidden, and had more park and less hard infrastructure. But you know, that's the next project. We're going to bring that in, I hope. Any more questions, Catalina?
I'm going to throw it out to the public there. Any questions? Anyone have questions on this? Anyone?
So we'll wait on the next question, but the Mayagüez project, the left screen is before construction. The bay bottom, you could not see the bay bottom, right? It was completely polluted from runoff, even on a dry day, which is that image on the left.
Wow.
The image on the right is 3 years after construction. You see the constructive wetlands are not that big compared to the whole park, but it's a way of handling that upland flooding with some of the surge. So that wetland is crucial to not only polishing and cleaning up that water day to day, but when there's a surge event coinciding with a heavy rain event, that upland strategy, that cloudburst strategy is what gets us there. And our big point that we want to take away, give the team to take away, especially the electeds, is as we're today discussing Army Corps, at the same time, there's a lot of efforts with cloudburst infrastructure upland. And so if they coincide the surge with the rain, and think about the federal procurement cycles that are required to pull that off, that are in line with the political cycles, both at the White House, Congress, and Senate. And so it's a multi-layer political juggling that should be coordinated and led by civic groups such as yours, Catalina, as well as the elected city council members and Senate and Congress. This is a photo before and after Hurricane Maria. This is before. You see mangroves and oysters and salt grass. I know we're pushing a lot of oysters into New York Harbor, which is very exciting, but they do really well, and they survive the hurricane and continue to clean. This is taken after the hurricane, right? Now the dunes were able to manage a lot of the debris. So the forest kept a lot of the floating docks and broken boats from coming into the city, and then the multi-layered wetlands were able to manage the surge from rain. So, you know, the two-part system that coincided a day apart, heavy surge and then heavy rain, and the system helped manage that. And you see some of the data from that event, but it maintained positive drainage throughout the storm for both rain and surge. I'll leave it there.
Well, Walter, we've just got one dilly of a question from Dan Wiley there in the chat. How did you get, and all the acronyms he lists there, to work together or not cancel each other out? I mean, that's probably a whole novel length answer, but go for it. Yep, I think we've lost Walter again. Maybe he's got his background noise. I'll give Walter a moment. Walter, can you hear me?
Yep.
Yeah,
Sorry,
Dan,
just,
you heard me. Dan Wiley asked how you managed to get all of those, the alphabet soup of all those agencies to work together.
Go ahead.
In the chat, Dan Wiley from Congresswoman Indy Velasquez's office posted a question as to how did you get that whole alphabet soup of agencies to work together? Can you hear?
So yeah, what is typically done in jurisdictions is an integrated resiliency plan is created that then becomes a framework for the future funding. Like Tom is in DC, Tom Asbery and Scott Davis from FEMA and HUD. They're in DC because we have the IRA, we have the BIL, there's a lot of funding coming through. Question is, how do we integrate is when you get several federal agencies as well as the marketplace all pulling in the same direction. That's where we get the most bang for the public dollar. And so I want to show you an example of that. Red Hook is unique in that it is a place where a large percentage of the shoreline is owned by local property owners. Yes, there's a lot of last mile ownership from Goldman Sachs and Thor Equities, but most interestingly, some of the local property owners who are community members, who are the landlords of these great businesses that Red Hook's so special, have indicated that they're open to conversations around, offering easements within reason, of course, if they don't have any penalties for loss of floor area ratio and such. But imagine, especially what's interesting is these private property owners that are local own the most vulnerable parts of Red Hook, which are the zones that are exposed to the most fetch, right? The most open water on the shore. Now, interestingly, I want to point out that we also have an important public ownership, and I come from a family of wooden shipbuilders, schooners and things. And for me, the industrial working waterfront of New York City is critical to maintain as a linear footage, and it needs a different strategy than just these living infrastructures. It's where especially I see the home for these dynamic walls. And one of the ideas came up earlier was, how does the dynamic wall that was presented earlier coincide with some minor rain events or surge events? And so if you were to raise the roads just a little at the entrances of these industrial working shorelines, it would give you like a mild berm that buys some time for evacuation during an oncoming surge. And so it would slow the release of the wall around a street entrance, for example. So my point is to integrate topography in the city making process, and then let that be a frame, the resiliency plan for Red Hook to be a frame for bringing in federal funding, as well as any real estate or market interests, or P3, such as Port Authority, who might run RFPs for future development. We can take those public parcels and create new layers in them that are requirements for developers to go beyond the building code with an overlay district. So it's a little bit of zoning, it's a little bit of anticipation of federal resources. This is a marathon, not a sprint, is the old metaphor, but we have to have a big frame for this that holds it together, a very clear frame that all the electeds can push out and speak from the same voice on. I hope that answers the question, Dan.
You've done admirably, but I guess Red Hook initially had an integrated flood protection system kind of plan, but then they dropped the integrated from it. So, and then you have certain pots of money that are dictating what the plan is over others. So it's a little backwards in this case, but it certainly is inspiring what you presented, that what could be when it comes to integration.
Thank you, Dan. It's important to show things that have been built and have been tested by nature. It's not enough to just, have plans and ideas for experimental technologies. That having the Dutch metrics is really important around maintenance. The maintenance is not that big of a deal, but you have to have a program for it. I always wish, Dan, that we created an office of the coast for New York City, a coastal commissioner whose budget would be the maintenance of these coastal systems, meteorology, all these. There's a climate office, but we need a coastal commissioner somewhere in one of these agencies that integrates all the coastal issues, which are different than just harbors. It's all from Rockaways to Red Hook. The coastline is a very different knowledge base, and it interfaces with some of the industrial maritime uses that are there as well. That is an endangered species, is the linear footage of working waterfront in New York City.
Okay, anyone else on this one? Oh, there's something else I see in the chat. What is this? Okay, then I think actually, Walter, that would be a wrap for your section. And we're going to switch over to a proposal that we're going to show via video. So this was an Alex Washburn project with people working for him. A completely different version or solution from the other two proposed. Now it's a barrier island called Red Hook Island. And we had actually found, PortSide had found evidence of a prior plan, and so did his team. I think it's 1921. When there was this proposal to have a barrier island, a development off the Red Hook shore. It wasn't completed. Actually, it shows up in Red Hook Water Stories with the interviews with Don Horton as Red Hook Flats during World War II. And I guess, Peter, you posted something in the chat, but there were, subsequent to the original approval, there were two other 1930s airport. What's the other one? Wow, Dodgers out in the water. I mean, I missed that somehow growing up in Brooklyn, but there you have it. And so his team found this, and so his proposal is based on the idea of protecting Brooklyn. He says, if Brooklyn's at risk, what's the answer? More Brooklyn. So it would make it not solely a natural island that would have some park in it, but to actually use the real estate developed on this barrier island to pay for the whole thing. So it therefore has no cost. So Peter, let's see if you can let that run. Thank you. Well, Peter said, I want to thank Realty Collective again for letting us come here. There wasn't enough room for all of us to be on the Mary Whalen doing this. Yeah, oh, there we go. Okay, we're working on the volume here. Peter got it rolling, but there was no volume. I'm going to remute myself. Did anyone else hear the volume of this? We tested this earlier, but I don't know why it's not working now. Did you change the setting? Wow, they can watch it later. Oh. Go. It's not working. It's not working. Let's stop it here.
As you guys are bringing that up, I don't know if my alert's coming through, but I can talk.
Stop. Here, you gotta mute it.
Folks, we're going to give up on that because we don't know why it is. We have no idea why it's doing that. We tested it earlier. I'm sorry, it's late, but being a video, have you posted the link to the video in the chat, Peter? Or I think it's, we have it, I think he posted the blog post. So our blog post has both video embedded, a PDF that Alex Washburn had sent us, and a slideshow that was made from screen grabs. I will say that, and I'd be interested if Dan Wiley, you are still on. Yes, I see that you are. You know, the chances of getting something like this permitted. I mean, in my time obsessing on New York City's waterfront, which starts in 1998, it's gotten ever harder to build anything in, on, over, or next to the water in the main due to the New York State Department of Environmental Conservation, or the DEC, which has, I would call it a rather fundamentalist approach to any man-made structure going in the water is a super negative. I saw Brian Robbins was on the Zoom here earlier. If you're still there, Brian, actually, we would love to hear from you with the final few minutes. He told me sometime around 2018 or 2019, I think it was, he was interested in actually reconstructing a pier that had formerly been on his property. The DEC at that point was willing to now let construction in the water for maritime activity, but said that he was going to have to pay 40% of the cost of the entire project into an environmental remediation fund, which just increased the cost of the project enormously. So Dan Wiley, if you're still here, what do you think are the chances of anything like a Red Hook Island ever being permitted? Or is it really just a kind of compelling pipe dream? Are you there, Dan? I heard baby sounds earlier. Walter?
Were you directing it at me? Yeah, I do have a 15-month-old who's fishing.
I know, I could hear. It's lovely. And say hello to your other one for me, please. Yes, I was wondering, are you familiar with Alex Washburn's Red Hook Island proposal? And if you are, do you think that it has an ice cube's chance in ever being permitted to occur?
I'll take the Fifth Amendment on that.
Very diplomatic. You always are. Okay.
And I'm afraid I've migrated north to Annabelle Basin and Newtown Creek area in Queens and Brooklyn. So
you're off the hook.
I will defer.
That's right. Literally, as Jackie said. Walter, would you like to say something? Your connection's wobbly. Now you're muted, Walter. Did you want to say something or are you muting?
I got a lot of background noise. Can you hear
Okay, got it. Oh, look, there's a comment here from Oliver Femont. They were hoping to come to New York for the UN Water Conference that were held up here. Well, if you visit, we would definitely love to meet you. And thank you very much for staying up super late to present to us in New York. I think a lot of people here were very interested and excited with your presentation. And I know other people who've gotten in touch expressing their regret they could not be here and asking for the recording. We'll be checking in with this.
All right. It was my pleasure, really. And we were hoping to come, but yeah, well, too much work here. So in any way, we'll try to answer all the rest of the questions tomorrow, the next few days. And thanks for your hospitality and the opportunity.
Our pleasure. Thank you. Anyone else have a final comment or question they want to lob anybody's way here before I call it a wrap?
Yeah, the noise background just finished, but I was going to add that permitting in the water is difficult, and the further you go in the water, the harder it is. It would require some changes in the laws, Title IV wetland laws and such. And so I will also add that none of this Army Corps work can happen without a clean site, and anywhere in New York City has polluted soil. So there's some organizing that the electeds need to do to get some federal funding from other tranches other than Army Corps to get some of these polluted sites cleaned up so that Army Corps can do their work. So that's one big thing to look for. That's like the 10-year challenge, right? This is like 10 years of work, right? This is not going to happen next year. But there's things we have to do to speed that up as the local electeds, and so that is one of them. Got to clean up the soil where a wall might go or where a new berm might go. My dream is to take a lot of it in our office, take the Brooklyn Greenway and run it out as a barrier that protects Red Hook along, some of the O'Connell organization's properties and other things. That solves a bunch of problems, solves our mobility issues, waterfront access, as well as surge barriers all in one. And then where you have industrial areas, you have your floating walls of the surge powered walls, right? It's not that simple, but that's the approach that we would see in the next round of work.
So I just spotted Donna Newton from Assemblywoman Joanne Simon's office, and Jackie Painter here said that she'd seen staff from Councilman Alexa Aggéres's office Would any of the staff of elected officials like to speak up? Oh yeah, Andrew Granardis, Carlos was here. Oh, we got some street guys. Any of you want to say or ask anything?
I just want to thank everybody for this. This has been really incredibly educational, and it's a wonderful thing to see that there are alternatives that should be considered. And I'm looking forward to discussing it with the Assembly member.
Thank you so much. Anyone else?
Yeah, well, thank you, Carolina and PortSide, and thank you to all the presenters. I think this was really, really excellent, and I learned a lot, and I'll definitely be taking it to Senator Andrew Granardis. I'm the district director, and yeah, this is really great. I do have actually a question, if it's okay, for the first presenters, Aggéres, and it's about the has it been tested, the floating wall, has that been tested in like an extreme weather circumstance, like hurricane in a coastal city, because that strong currents, winds, water, possible big object debris, that could present a challenge. I think the biggest fear is that it maybe would not fully be able to function. So I want to know, like, has it been tested in any extreme weather circumstance in a coastal area? And also, what is the typical difference in cost within, like, it's a standard seawall as opposed to these floating walls?
Well, good questions. I try to answer them in the chat as well, but we don't have that many hurricanes here in Europe, so we'll have to go by say, but there is an installation we know of that is in Washington, D.C. at the National Archives, where there are two 30 feet long, 9 feet high barriers that were activated during Sandy and protected the National Archives from flooding at that time. There are no pictures or no video material available from the activation events, but we heard that it protected at that time. Regarding the cost, depends on what price you can put on the cost of living. Is do you want to be behind a big gray wall? And what we always used to use in presentations is the city is there for a reason. The city is usually alongside a waterway, or the spot of a city is chosen for a certain reason. And New York is chosen for its rivers, the Hudson and its Bay Area. And closing off your city from the reason of existence is the waterfront is something that should be considered carefully, and being able to have the same level of protection but keeping the contact with the raison d'être, the reason of being there. Yeah, what's the price on that? What we know for sure is that when you compare it to glass walls or to other types of systems that keep the visibility on the river, is that we are perfectly on a level base, maybe even cheaper if you take the life expectancy of 100 years, because you have your investment at the first stage, which is the bulk of the cost. The big part of the product is that the maintenance cost at a later stage is very low. Therefore, if you take in account that you have your life cycle cost, and you take in account that you take your life cycle cost over a 50 to 100 year period, this system will repay for itself in comparison to other systems where you would have cleaning, graffiti removal, and all these kinds of things that would make a running bill.
Thank you so much. I really appreciate you guys taking the time in another time zone. for the presentation.
Yeah,
Okay.
the graffiti removal cost, that's astute, actually. I hadn't even done the cost of removing it, what the walls would end up looking like in a short period of time. In New York City, that is actually, that's quite a thing. Thank you for that question, Carlos. Anyone else? Brian Robbins, are you still there? I see your face in a static photo. Because you're a waterfront property owner. No answer. Okay, well, if there's nothing else, I think I'm gonna. Oh, the comments. Oh, yes, exactly. All of you who are New Yorkers, please submit comments to the Army Corps, okay? It's been a lot of work to get them to give us all some more time. There are a lot of concerns. We posted on our blog, PortSide did. I thought they were very smart. There were some tips on writing comments from Councilman Lincoln Ressler, which was if you feel like, well, gosh, I'm not, a marine engineer, I'm not a construction expert, what do I say? There's some very helpful to talk about what you know and what you care about. And I think the most important thing is to just speak up. If you do not speak up, you cannot be heard. Okay, and so I've been hearing on the street, on Facebook, and lots of places, lots of concerns. Those concerns have to be shared. If you have proposals, it's always good to be constructive, but you got to speak up. All right, I think that's it. Is it a wrap, folks?
Oh, I have one thing, Carlina.
Good. You always have good stuff. Let's have it.
Well, right now we're dealing with community project funding, so we're just thinking of certain buckets that we have to fund, and we're always thinking in terms of what the funding is coming from. I think, since Rep. Goldman and Congressman Velasquez together, asked for this extension on the public comment period until the end of the month, we should definitely take advantage of that. And I think it might be relevant to encourage, interagency coordination, of course, is something that has to happen. And there is a local cost share. So I did show the video, Aggéres, a video to the chief of the branch at Army Corps of Engineers. And, the reaction was kind of, was open to it, but with a kind of caveat that, well, this is a lot more expensive, and that means the city needs to, like the locality would need to pay for it. So there is always the issue of, there's federal money, but it also has to be local money. And if you look at East Side Coastal Resiliency, the city, the lion's share of the money is actually coming from the city. But of course, that's a different pot of money with this CDGB and funds. But the city has to step up, I would say. The Fed can do a certain amount, but the locality has to do a lot. And even in these studies, there's a local cost share for the studies. And then for the implementation, there's a different ratio cost share. But there's always cost share. So I would say the interagency coordination is a very valid point.
Well, actually, now there's something that I want to say. So, Oliver, if your team would like to take on the following, I was just astounded. Put it this way, I got very excited about your surge-powered flood barriers when I found them in 2017. A date burned in my memory. I can't remember how I found it. I remember I was all excited on Twitter. And then more recently, when I saw the city take this approach to destroying the park in the Lower East Side, and then the amount of demolition costs and raising of earth and whatever else, and I kind of kept thinking, wouldn't the installation of these self-controlled, flood barriers be not only less destructive, actually less expensive? It's a much smaller trench relative to the, large scale sort of thing. So, I think for your firm, Oliver, is if you were to run some cost comparisons on what doing a segment of your wall would cost in New York City terms, I don't know if that's possible, because you can hear people keep asking about the cost and who's going to fund it. It's interesting to me. The Army Corps would presume that your wall is more expensive than their static wall. I would look to know if your wall would have been cheaper than what's going on in the Lower East Side park. And so I guess we're all, without any kind of specifics, your product is very tantalizing, but it's really kind of hard to know. And if we don't really know what it costs, it's going to be easier to
shoot down or for us not to attain that because we don't know what it costs. Sorry, that was a bit of a ramble. I can't claim it's late for me because it's much later for you, but I hope that was intelligible.
No, I'll try to get some numbers exact. I'll try to get into depth in what's needed, what we could propose, and we got some similar projects here in Antwerp where we have a raised embankment, which is only 3 feet high, so you can walk over it, have a view towards the city, and then have half of the barrier coming up out of that embankment. So you would have both of solutions, but not the 10 or 12 feet high wall. So there are different options, and then all depends as is how deep do we get into the ground, what cables, what is there in the ground, and then so I can start throwing out numbers, but I'd rather give profound and numbers that afterwards that we come, if you come back to us and you said you gave us these numbers, but these are not realistic. So
here's another way to put it. For example, if I understand correctly, someone asked the question, they were asking, I think, basically the width of the trench. So if you could make a comparison, like looking at actual New York project, like possibly the Lower East Side one or something. In other words, that we do what we would do here, and I had actually wondered about the berm. You know, scenario A, berm with our SCFB on top of that, and that requires that we need to demolish however many feet wide of this area. And so that you don't have to do all the complete cost estimating, you know, for business in New York, but they can have comparables. I don't know if this works, but I'm thinking it would be a rough comparable in terms of construction area. In other words, if you're going to have to hire the local contractors to make the trenches or something like that, how does your trench compare to the other trench for some solutions like this? Because the current project is overhauling a massive amount of terrain. And the other reason why, going back to Reddick very specifically, I was particularly interested in your product, is we have a very old settlement pattern where our buildings really right up close to the water. And so that if the wall is introduced there, it dramatically changes, as you were talking about the experience of, you know, the city and why do we have it here besides operational issues. And so therefore, if the wall, much like in the Spakenburg case, was not there all the time, you could have a community, it's built environment right up next to the water. And in some cases, we have boats, not as many as those lovely Dutch flat bottom boats there in Spakenburg, but you know, that isn't ruined. So there were obviously cases in Red Hook where the narrowness of your trench, in other words, if you could put that in Spakenburg, that was really very encouraging. So maybe that's a way to do the cost comparison is the square feet or cubic feet of disruption that you need to execute.
Yep. No, I'll give a presentation, or I'll send you some details on how we could resolve. I think it's a 12 feet high flood wall that they're intending to do.
I confess I've forgotten. I think that's right, but Dan, do you know?
Hey, this is Tom Asbery. Yeah.
Oh, you would know.
In different locations, it will be various heights, you know, depending, you know, the highest portion of the wall might be 12 feet. It could be 9 feet, depending on the location of it. What I posted into the chat is right from the report. Here, I'll add page 199. And
Yes.
this may be an easy comparison for Oliver, is that on the Gowanus Canal, they're proposing a miter gate. So you have a 200-foot closure structure, but what's going to be the navigable passage is 100 feet. This still would be minus 21, and then it would be plus 16 above the surface water at high tide. You know, so if you were able to deploy, you know, something across the Gowanus Canal, you know, how might that look in terms of a cost estimate? because the surge barrier is what's proposed at the Gowanus Canal, but they still haven't completely designed it. They've used this other surge barrier technology, but I don't know if your technology was considered, if that helps.
Well, I'll have a look into it and give me a couple of days. And I'll get back to with some profound and under some numbers that we can really relate to in the future as well.
Great, thank you.
All right.
Yeah, and I would also just add that we have Newtown Creek also that has a surge gate, and then walls and flood walls and sea walls and whatever kind of walls on either end. Going down to Greenpoint Avenue and going up to Annabelle Basin in Western Queens. Similar problem situation, where Hunters Point Park, they want to have, green infrastructure and kind of open to absorb water as opposed to this hard walling off the water. So it's a similar condition. So I found this very inspiring for all areas, including our new areas, and also for the area under the FDR on Manhattan. In Manhattan, they do have flip-up barriers or deployables underneath the FDR Drive as a proposed, as a solution. So there is kind of a patchwork of different things as you go around Manhattan. So I think there's potential there in other places.
I saw these two in a couple of presentations. They exist as well. The flip up barriers. We have variants on those as well, but they are still more mechanical than the SCFB or the barrier that I presented, and therefore the chance of failure is for us is the highest level. And therefore if we can, and there is the depth is possible, we always present the SCFB. If there would be issues with the depth that we can go into the ground, flip ups would be an alternative. But yeah, all right.
And that's interesting point. That they're more the flip up is more mechanical than something that is surge activated. And what can you explain why it's more mechanical?
Well, you would have hinges. You would have the most mechanical flip up barriers. They flip up away from the water, so the internal components and the strengthening beams are at the water side. Those are quite vulnerable for impact loads, and then they could, if they the struts, I think, is a that keep up the flip ups. They are quite vulnerable. Also, you have autonomous flip up barriers that flip up with the water level, but those water levels always are at the point of flooding that they flip up. So we are able with our system to have them come up at a lower water level than when the flip up the other types of barriers. And well, we have both, and we present, and we have projects where we have the flip up because of the SCFB who couldn't be dug in at that certain spot. So it could be a combination of several systems working as one.
That's really interesting, and I'll just plug Hunters Point Community Coalition and Long Island City Coalition and Annabelle Basin and the Western Queens Community Land Trust. They're in the same boat as you guys, Red Hook. So let's all work together.
Dan, one follow-up question for you. Oh, Dan, did you just leave? No, there he is. So Peter and I were on the Zoom that Congresswoman Nydia Velázquez organized about for new Northern District there. And I thought, I heard the Army Corps presenter say something about the possible necessity of moving the Newtown Creek wastewater treatment plant. And if that's true, could it be protected by something by the I always get the acronym, self-control, SCFB, rather than moving a whole wastewater treatment plant? Because I thought, wow, how expensive is that?
No, actually, what would be moved is the outfall pipe, the effluent pipe from the plant. So instead of the plant putting out its effluent into the creek inland of the surge gate, it would need to be relocated so your outfall is outside the gate, right into the East River.
Gotcha. Then I
Right.
missed that. Okay, gotcha.
But it points up to the point of you got all these CSOs, and if you build really good barriers along the whole coast, you have a high water table, and you have all kinds of rain and combined sewer overflow happening. Bathtub effect question. So it's not just a question of the main pipe that drains, where the water is put out from the sewage treatment plant. It's also all those combined sewer pipes that have outfall. In the case of Gowanus, around Gowanus, also in Newtown Creek. So that's a huge issue in both areas, how the drainage works. And of course, I know Red Hook has asked for a drainage study. Gowanus has asked for a drainage study. Newtown Creek has asked for it. Everybody wants a drainage study. We just broke ground on overflow tanks that will help the situation last week, but it's not a full solution.
There was somebody, actually, I wanted to now ask about CSOs for the non-Americans here, the combined sewer system that we have in New York. How, Oliver, would your product, how would those work with our CSOs? So what happens is when, once upon a time, we just put all the sewage out of the harbor, and then there was a Federal Clean Water Act of the 1970s, that couldn't happen. And so then the sewage that would be running out of the harbor, other pipes have directed them off to waste transfer stations. But when we have a large rain event, as they put it, the storm drain water comes off the street, goes down to the storm drain, goes into the combined sewer, and then we have the stuff going out into the harbor. So we would not be able to have a barrier going down there. And I don't know, Dan, Wiley, whether you want to help answer that. Like, where does the CSO go, or do we have to have retention tanks like in the Gowanus if we were to introduce an SFCB along our waterfront where we have CSOs? There are quite a few CSOs in Red Hook. I don't know whether it's an Oliver question or a Dan Wiley question, or both.
Well, first, I would say that if you have something that's deployable is not always up, then if there's a cloud burst, but it's not, and your surge, there's not a surge, but there's really rain, then then you have better runoff because you don't have a static wall holding everything in like a bathtub. So I think that's a plus for this approach, right?
Yeah, but what I'm saying, if the wall goes up, the current location of the CSOs, the wall, because they're right there. I can see them at very low tide, right. They're visible in Atlantic Basin. So then what happens then? Because if the wall were to go up, it's blocked. And so.
But actually, the wall would work one way. The SCFB will protect Red Hook from flooding out of the sea area. But actually, the basin drains towards the sea or the canal or the water, the body of water. So if the water comes from the hinterland, it would drain the water or let it flow over, but it would not pop up unless there is a high tide at the same time.
Right, that's the condition I'm wondering about. So in other words, in the condition of Sandy, we had seawater coming in, not the heaviest rain coming down, but some. But there was enough that there was sewage water and groundwater, surging into Red Hook. So if there's a big surge of sewage and the wall goes, actually, I'm sorry, it's a granular question, I think, for this event, but it would need to be resolved somehow. Because we have that right there, so we don't basically have the sewage hitting the wall. So I think that's for another time. All right, anything else, anyone?
But I think you raised a good point there where if you have sewer outfall pipes and you have a wall blocking it, how do you have the wall not block that? I mean, of course, you have the backflow preventers too, where you don't want the surge then to back up into pipes going the other way too. So
Yeah,
it's
you
a
don't,
two-way
exactly, you
street.
don't want to force that into people's homes, or we just have more, sewer users in the street, so that's a city fix, that's not, I mean, he doesn't know our city sewer system, but there's a lot here that needs improvement in New York, let me tell you. Anyway, I think we should call it a wrap and let our Belgian colleagues go to bed. It's incredibly late over there. Thank you all so very, very much. Thanks everyone here for participating. We will tomorrow get on to sharing the chat and recording, okay?
Perfect.
Thanks to you all very, very much.
Thank
Hello,
you.
Sam.
Thank you.
I really
Thanks a
appreciate
lot.
it. Really,
I
really
want
appreciate it.
current page of cyanide versus lighter.
We all want different things.
Boats, more boats. NYC needs more piers for boats. Good night. Thank you, Oliver and Anthony, very, very much for staying up so late for us. All right, I'm gonna
Hey, we just ended the call.
end meeting for all.